All right, good afternoon, grade sevens. I hope that you guys are all doing really well today and that you guys are having success with the exams that you've been writing so far this term. We are back again, guys. It's time for the 24th lesson of the year, which is quite impressive. We are just past the halfway mark of the academic year now, guys, as far as weeks are concerned. I know that there are still another two terms for most schools, term three and term four, but it's usually the first half of the year that's a little bit longer. So, um, we're back again for another lesson. Like I said, now week 24, and I hope that you guys are ready to get some work done. We are finally done with a lot of the foundational work for grade sevens. Uh, in the sense that we've covered all of the basic things that we've been talking about for the last few years already. Now, there are some topics that we are learning about in grade seven that are preparing us for high school. And one of those topics is the world of algebra. So, for the last 2 weeks, we've been discussing quite a lot of information when it comes to algebra. And today, we want to dive into a little bit more detail. We want to continue building our momentum in this topic. And continue developing our understanding of what algebra really is. Okay, so just very quickly before we get started with today's work, I want to give everybody just 2 or 3 more minutes to quickly join us, and then we will get started. But I want to quickly remind you guys of what we are talking about when we discuss the world of algebra. So, algebra remains one of those topics that seems very mysterious and quite intimidating, to be honest, at grade seven level, guys, as I'm sure you know. But we've spent a lot of time trying to understand what algebra really is. It isn't just numbers or letters that can be any number that we want. There's a lot more nuance to it, okay? It's not just that easy. So, what is algebra? Algebra is the more grown up version of missing number problems. Okay. It's the way that we write math sentences to help us work through problems to find some number that we are looking for, right? A lot of the work that we do in primary school involves us learning how to work with numbers, right? So we're given two numbers and we have to learn how to add, subtract, multiply, divide, square root, and so on and so forth. But algebra and high school maths has got a lot to do with being given certain information that we need to use in order to find some missing piece of information that we want to identify. So, algebra is the foundation for these missing number problems that get slightly more complicated as we move through grade seven and further through high school. All right. So what I'm going to do is start by sharing my screen with you guys, and we're going to get going with today's lesson. I want to quickly remind you, while I have your guys' full attention, that we do keep recordings of every lesson that we have. And over the last 2 or 3 weeks, like I said, guys, we've been discussing a lot about algebra. So if you have missed our previous lessons on algebra, it is very important that you go back and watch those lessons because a lot of the work that we discussed in those previous lessons is going to be used in today's class. Okay. With that being said, you guys are more than welcome to ask questions. And while I've been talking, I've been scribbling on the screen over here, so you should be able to see what I'm writing. If you guys have any problem during the lesson with seeing what I'm writing or hearing what I'm saying, you need to please let me know so that I can fix that issue. All right. So let's get going with today's work, guys. Today's date is the 24th of June 2025. You can write it in the English fashion or you can write it in the typical maths form. It's completely up to you guys. Okay. And today's heading is going to be algebra, understanding like and unlike terms. Understanding like and unlike terms. Okay, quite a long heading, I know. All right. Okay, so guys, we need to dive into a new aspect of algebra today, and that is dealing with what we call like and unlike terms. Okay, so we're going to start by talking about what like and unlike terms are. But let's quickly go back to some of the work we covered in a previous lesson. If I give you the following maths sentence, algebraic sentence, we have x plus 2 plus 3x. We learned that plus and minus signs help us to distinguish and identify different terms. So over here, we would have term 1. Over here, we would have term 2. And finally, this 3x over here, right at the end, would be considered term 3, right? So these are what terms are. They're the separate little pieces that we work with in a algebraic expression, in an algebraic expression. So in order for us to understand what like and unlike terms are, we need to already be able to identify these separate little pieces that we are sometimes going to be asked to add and subtract, right? Now, how do I know what is considered a like term and an unlike term? Well, I'm going to tell you guys right now that x over here and 3x that we see on the right are like terms, right? These two can be grouped together. We can add them together. But the two sitting in the middle over here is a little bit of a lone wolf, right? It's not the same kind of term as term 1 and term 3. So unfortunately, we cannot add this number 2 to anything else. So our goal is to now figure out what exactly makes two or more terms like terms, or what would make them unlike terms. Okay, so that's what we're going to start with in today's lesson. Please remember, if you weren't here for previous lessons, that it would be very beneficial for you guys to go back and watch the recordings of our previous lessons. So we have two different types of terms, right? We have a like term, and I'm going to write this in yellow. I'm going to use the color yellow for like terms throughout this lesson, so you can pick a color that you would like to use. So what are like terms, grade 7s? Like terms are any two terms with the same base, okay, with the same base. In this case, we're going to consider this our variable. Let's just leave it as base for now. Terms with the same base and the same exponent, right? Any two terms with the same base and the same exponent. So what would unlike terms be given this definition? The word like and unlike are opposites, so the meanings of like terms and unlike terms are unsurprisingly opposites as well. I see someone's asked how I'm doing. I'm doing very well, thank you guys, and I hope that you are also doing really well too. Okay, so what are unlike terms? Let's define them. Unlike terms are any two terms with different bases or different exponents. And I want us to write a little note, a little diagram of sorts on the side to help us remember what this means. Remember, if I have something like x to the power of 2, the letter x itself is considered the base, and the power that we see, the number to the top right, is called the exponent, which is what we are making reference to in these two definitions. Remember, an exponent is also sometimes called a power. So make sure you just write this somewhere nearby. It doesn't have to be in the same place as me. So we are busy talking about these types of terms, like and unlike terms, but why do they matter? And we're going to take a look at some examples now. So just bear with me for a second. If I have a sentence like we spoke about earlier on, let's say I have 4x minus 6 plus 2 minus 2x, or just actually minus x. We eventually start working with math sentences like this, grade sevens, that can get really, really long, and we can have all kinds of things that we plus and minus for pages. So, to stop us from working with all of this repetitive information, we choose to group the things that are like terms. So, for example, in this case, and we'll discuss why this is true now, the minus x and the 4x are what we consider like terms. So we can group these together. In other words, we can plus or minus these. And then there's also going to be this negative 6 plus 2, which we can also group together. And I'll show you how we get the answer later on in today's lesson. But the answer for this kind of question is going to be 3x minus 4. Why is that beneficial to us, grade sevens? Because this step at the top contains a lot of repetitive information, right? It's similar to saying I have a square plus a square plus a triangle plus a square minus a square plus two triangles, right? Instead of having such a long sentence, we can group things together. A square and a square makes two squares, plus another square makes three squares. But then we take one square away, so we're down to just two squares, right? Looking at our triangles, we then have a triangle over here plus two triangles over here. So we have two squares plus three triangles, right? We are doing exactly the same thing, but just with some more formal writing. Okay. So why would we do this step over here? We would do this because it helps to get rid of all of the repetitive clutter in a question. And it leaves us with something that means exactly the same thing as this step above, but it's shorter and easier to read. So when we talk about these like and unlike terms, we see over here we have 4x minus 6 plus 2 minus x. All of these things can be carefully combined to give us an answer of 3x minus 4. Okay. And this step, where we move from something that is a lot more complicated to something a lot more simple by grouping like and unlike terms, is called simplifying. Right? We're trying to make something simpler to read, simpler to work with, and simpler to understand. I hope that this makes sense, grade sevens. So you can quickly write this down as an example if you would like to. Okay, I know it's not super neat, but I know some people like these examples. So if you'd like to copy this down very quickly, you're more than welcome to. I'll leave all of this work on the screen, but I will delete this in 2 minutes' time. So quickly copy it if you'd like to. You have 2 minutes. If you guys have any questions, please make sure that you also ask me. I am here to answer all of your questions. One more minute to finish copying, and then we're going to move on. Okay, what we're going to do is write down a definition for simplifying and then look at examples of finding like and unlike terms. Okay, so that we can put this into practice. All of the information is important, but practice is even more important. 1 minute left, like I said. Okay, so I'm going to actually just move this over to the side in case anyone is not done yet, but we will come back to it. So let's quickly write down a definition for simplifying. This is a very important definition, guys, because it's going to be a word that you come across every single year until you finish school. Simplifying is the process of combining like terms during working out to group similar information, and avoid unnecessary repetition. Right, quickly write that down. And when you are done with that, you can also go ahead and make a small subheading under this called examples. You can also then write a question alongside your heading in brackets. And we're going to dive into some questions that will test your understanding of like or unlike terms. And I will be giving you guys some examples to try on your own. Right, so here are four examples that you guys can write down as soon as you've done the heading, and also remember to add on number 5 at the bottom. Right, there's the 5 examples, guys. We're going to go through these one by one and identify or explain why the terms that are found in each question are considered like or unlike. Right, so let's quickly think about the definition for like terms. We know that like terms are any two terms with the same base and the same exponent, right? Quickly copy these examples down, guys. You've got 1 minute, and then we're going to go through them one by one. After that, I'll give you guys some examples to try on your own. Quickly copy all of this down, please. Right. Let's start by taking a look at example number 1. 2x and just the number 2. Are these like or unlike terms? Well, let's start by asking if they have the same base. In the first example over here, x is the base, and in the second number, 2 is the base. So already there's a little bit of conflict here because we have two different bases. But let's talk about the exponents. We know that when we cannot see an exponent on a number or a variable, it is always going to be an imaginary one. So, do these two terms have the same exponents? Yes, they have the same exponents. But do they have the same base? Right? Is that exponent number 1 attached to the same thing in both examples? No. Over here on the left, the base is the letter x, and on the right, it's the number 2. Right? So they do not have the same base. So what does this tell us about whether these are like or unlike? Remember, the definition of like terms is that it's any two terms with the same base and the same exponent. They must have both of these requirements. Unfortunately, in example number 1, we only meet one of these requirements. We only have the same exponent. So these would be considered unlike terms. What does this mean? If you gave me 2x plus 2 in a test, there is nothing I would be able to do. This would be the answer. Because they are unlike terms, I cannot add them together. Okay, I cannot group them. So, unlike terms, what is the reason? Uh, they have the same exponent, right? But they have different bases. And please, guys, make sure that you write the reasoning down because it's going to remind you why they are unlike terms at a later stage after you haven't looked at this work for a while. So let's then take a look at number 2, x squared, or in other words, x to the power of 2, and x cubed, or x to the power of 3. So let's start at the beginning. Do we have the same base? Well, yes, we do. Both of these terms have got an x as a base, right? So these are the same bases. Do they have the same exponents? Let's take a look. On the left, we have an exponent of 2, and on the right, we have an exponent of 3. So, unfortunately, we do not have the same exponent. So, because it doesn't meet both of these criteria, example number 2 is also an example of unlike terms. Why are they unlike? Because they have the same bases, right? But different exponents. It's similar, it's the opposite reasoning to the first example, right? It needs to have both of these requirements met to be considered like terms. So let's take a look at example number 3 over here. And this is where some of last week's work continues to shine through. Y and 2y. Remember, if I look at the number 2y, only the letter y is the base for my exponent up here. Okay, whatever my exponent is, it's only applied to the letter y. The number 2 is not involved. Remember, this is called our coefficient. We do not worry about this. So, looking at our examples, y and 2y, let's look at the bases first. Do we have the same base? Yes, we do. Both of these have got a base of y. What is this base holding? It's holding up an exponent. So on the letter y over here, we can't see any exponent. So we must assume that it is the imaginary number 1. Looking at 2y, right? Again, I cannot see an exponent, so I must imagine or pretend, or actually not even pretend, guys. I need to know that there is an invisible exponent of 1. So, do these terms have the same exponents? Yes. Do they have the same base? Yes, they do. So, finally, we've come across our first example of like terms, grade 7s. Why are they considered like terms? Same base and same exponent. Okay. So what does this mean, guys? Why is it interesting? Why is it a good thing that we have like terms? Remember, like terms are allowed to be grouped. So if I'm given a question in a test where I have y plus 2y, right? It's like saying I have 1 chocolate bar plus 2 chocolate bars. What do I really have? I have 3 chocolate bars, 3y. Okay, so having like terms is important because it allows us to add and subtract algebraic terms. Right, it allows us to simplify. So, very, very important. Like terms is a very good thing. Let's take a look at example number 4. And then I will go back up and give you guys an opportunity to copy. Question number 4a is 6a and 6b. Remember what I said to you guys earlier, grade 7s. If I have 6a, because I cannot see the exponent, we must remember that there is an invisible 1. But The letter A is the base, not the full 6A, just the letter A. This number that we see in front over here is called the coefficient. And we do not worry about that when we are trying to look at like and unlike terms. Okay, please remember that. So, with that being said, let's take a look at example number 4. Do we have the same base? Well, no. Here we have an A and here we have a B. These are not the same thing. What about their exponents? Because I cannot see a power on each of these examples, they must both have that invisible exponent of 1. So, yes, they have the same exponents, but they have uh, different bases. Okay, they don't have the same bases. So, because it doesn't meet both of these criteria, these are unlike terms. What is our reasoning? Well, they have the same exponents, but they have different bases. So again, why does it matter that these are unlike? Because in a test or an exam, if I'm given the question 6a plus 6b and I'm asked what this is equal to, I cannot move on and find an answer. 6a is like having 6 chocolates plus 6b is like having 6 soccer balls. What is a chocolate and a soccer ball put together, guys? Can we put them in the same group? No, we cannot. Okay, you cannot add them together because they are not the same thing. They are unlike terms. Right. And for our last example, 4x and half x, right? Half of an x. Let's talk about whether these are like or unlike terms. Grade sevens, excuse me, guys. So remember, if I'm looking at 4x, like the first number, I cannot see an exponent, so there must be an invisible exponent of 1. What is the base, grade sevens? Is it x or is it 4x? Which one is it? It is only the letter x. 1 is only attached to the letter x, not to the number 4. Okay, so please be careful of that when you are trying to think of your bases. So, question number 5, are these like or unlike terms? Let's start by looking at the bases. This example here has a base of x, and this example on the right also has a base of x. So we have the same base so far. Looking at 4x, we cannot see any exponent or power, so it must be that imaginary 1. And the same thing is true for half x, right? There is no exponent that we can see, so it must be that invisible 1. Because they both have an exponent of invisible 1, they have the same base and the same exponent. So This is another example of like terms, grade sevens. Why are they like terms? Because we have the same base and same exponent. So, in a test or an exam, if I was given a question where I was asked to add these two together, 4x plus a half x, think about this carefully. If I had four chocolate bars plus half a chocolate bar, I would have four and a half chocolate bars, right? So we could either say that this is 4.5x in a decimal form like that, or we would have to write this out as a complicated fraction, which would be 9 over 2x. Okay, you'll learn about this step later on, but what I want you to remember for now is that because these are like terms, we are allowed to add them together. We've got the green light to go ahead. Okay, the rest you will learn about in due time, grade sevens. Right, guys. I hope that that made some sense to you. It's very important that we learn how to distinguish between these like and unlike terms. Why? Because they tell us what we are allowed to add and subtract, what we are allowed to group, essentially, what we are allowed to simplify. Okay. So I'm going to give you guys an opportunity to copy very quickly. You can see all of the answers and the reasoning behind it. We've only got 15 minutes left of today's lesson, grade 7, so please just stick with me for the last 15 minutes, guys. We're close to the end. Okay, so now that you guys have had an opportunity to copy, we're going to write down one more heading very quickly for just three examples. And then we're going to go and take a look at a quiz on iRainbow that you guys can then use to practice this work, right? I could give you 1,000 examples and sit and go through them with you together, but you need to try these on your own and test whether or not you are able to apply this reasoning, right? Whether you can identify if two terms have the same base and the same exponent. So you can finish copying those bottom three examples. If you weren't done and you need some more time to finish copying, please let me know at the end of the lesson and I will gladly come back to the screen so that you guys can finish copying. We're going to make another little heading, and the question is going to be simplify the following expressions. What does simplify mean? We want to group everything that is a like term and leave everything else alone. Right, let's just do 4 examples and then we will be done for class today, guys. Let's just do 5. Okay. Right. Quickly copy down these examples with the question, please. And then we're going to go through it together. And when we're done with these, we will be done for today, grade 7s. Okay, so guys, let's quickly wrap up with today's lesson and solve the following examples. Question number 1, 4x plus 2x. We can see over here that these two terms have the same base of x, and they also have the same invisible exponent of 1. So if I have 4 of these x's plus another 2 of these x's, you can imagine x as maybe a soccer ball. If I have 4 soccer balls plus 2 soccer balls, I now have 6x, 6 soccer balls. Let's take a look at example number 2. 3z minus 6. What is the base in each example? Over here on the left, we have a base of z, and on the right, we have a base of 6. Even though both of them have the same imaginary exponent of 1, it's still a problem that our bases are different. Because these are what we would call, let's actually do this very quickly. Sorry, guys. We found now in example number 1 that we had an example of like terms. So we were allowed to add them together. 4 plus 2 gave us 6x as an answer. In example number 2, however, we have unlike terms, right? What does unlike terms mean? We are not allowed to add these things together. So if I have 3z minus 6, unfortunately, I cannot simplify, and it is going to stay exactly how it was at the beginning, 3z minus 6, because they are unlike terms. Right. For the next 2 examples, we want to highlight like terms. So the number 18 and the number 6 are just normal numbers, right? 18 minus 6 gives us 12. And we still have this plus 2f. In this case, we have different bases because the number 12 has an imaginary or invisible exponent of 1, And in the second term, we have the base of f. And even though it has an invisible exponent of 1, the base of 12 and f cause a little bit of trouble. So we cannot simplify this any further, and it remains 12 plus 2f, right? Because they are unlike terms. 12 plus 2f. Let's take a look at example number 4. In example number 4, we have like terms, right? Let's see. 2c plus 3c. We have the base of c over here and over here, but in the last example, there's only a base of 5. For our exponents, we have an invisible exponent of 1 for all of these terms. So it tells us that these two first terms over here are like terms, so we can add them together. But the number 5 must remain on its own. So 2c plus 3c gives me 5c. And unfortunately, I'm not allowed to combine it with the number 5 because these are now unlike terms, right? And in example number 5, guys, 2x and 3x can be put together, and the number 6 and the number 4 can be put together. 2x plus 3x is like 2 soccer balls plus 3 soccer balls, which would give me 5x, right? We add these two together, and the number 6 and the number 4 can be added together. 6 plus 4 gives me 10. And there you have it, guys. There are 5 examples of how we would go about simplifying very simple expressions based on our understanding of like and unlike terms. Okay. I'll give you guys 2 more minutes to copy, and then I'm going to go onto iRainbow to show you guys an example of a quiz that you can use to practice this. Unfortunately, guys, we've only got 4 minutes left together, so I cannot go through more examples, even though I wish I could. All right. You've got just under 1 minute left. I hope that you guys have been taking notes. These will be very valuable to refer back to later, guys, when you need to revise this topic before tests and exams. Okay, let's quickly go ahead and take a look at iRainbow, guys. I'm going to stop sharing my screen now, and instead I'm going to bring up a slightly different screen, so just bear with me for a second. Right. So, grade sevens. When you guys are ready to practice this section of work and you want to try and test your understanding of this section, we are going to open iRainbow and we're going to start by opening the pink island of patterns, functions, and algebra. Once we've clicked on that, we're going to move across over here to this dark pink block, which is algebraic expressions, important basics. We're going to click on this, and then I want you guys to please make sure that you take a look through all of these different quizzes and try them at your own pace. But I also want you guys to focus on this quiz on the left-hand side over here called like terms, add and subtract, right? We're going to click on this and start with level one. We are asked here to simplify this expression. 5a plus a plus 4a. All of these have the same base of the letter A, and they all have an invisible exponent of 1. So all three of these are an example of like terms. So 5a, you can imagine it as chocolates, for example. 5 chocolates plus 1 chocolate gives me 6 chocolates, plus another 4 chocolates gives me 10 of these chocolates. So your answer needs to be 10a. We can press submit and see that we are on the right track. Right. Number two, 8q minus 3q. Again, it says simplify this expression. You can see this word already popping up, grade sevens. If I look at this example, the letter Q is the base for the left and the right-hand term, and they both have an invisible exponent of 1. So I can consider these to be like terms, which means I can ask myself, what is 8q minus 3q? It would have to be 5q. All right. And so you can see the kind of process we would go through to practice this section. And I really hope that you guys will use this quiz to your advantage. And if you feel really confident and you can get full marks for level one, try and make it slightly trickier for yourself and go ahead and do level two as well. Okay. You guys now know where to find this quiz over here. So I hope that you guys will use this wisely. And guys, that really is it for today's lesson. Okay, we are done. Um, grade sevens, there is a lot of practice involved with the world of algebra, and I hope that you guys understood, everything that I taught today, and that you found some value in the time that you spent with me. But guys, our next lesson is going to be next week, Tuesday, again from 4:45 to 5:45 in the evening. So I hope that I will be seeing you guys there. But guys, until then, I really do wish you the best of luck with the remainder of your exams that you have. And I will speak to you all again next week. All right. Thank you so much, grade sevens. Have a great evening further, guys.